Okay, now what we saw further previously is your concentration equals plus the amount of salt added divided by 10 pounds, 100 gallons plus the amount of water added. So, well, in T hours, how much salt is added? Okay, now you should be able to answer that question. And the same question for water. If you can answer these questions, then you replace this by the expression for the amount of salt added and the amount of water added by the expression you get for the amount of water added. Okay, so you want to stop and think about this. You want to stop and try to answer the question, see how far you can go with it. Okay, well, hopefully you stopped. Okay, in T hours, we add T hours times T hours times 1 pound per hour of salt, which equals T pounds. And in T hours, we add T hours times 10 gallons per hour of water equals 10 T gallons. So the amount of salt added in T hours is 10 T pounds. The amount of water added is, did I say 10 T pounds? I think I did, but maybe I was thinking about what I was going to say. Say it right. In T hours, we're going to add T pounds of salt, so you're going to have T pounds here. In T hours, we're going to add 10 T gallons of water, so we're going to have 10 T here. So now, C of T, our concentration at times T, it's going to be our concentration after T hours, is going to be 5 pounds plus T pounds divided by 100 gallons plus 10 T gallons. Now do the formal factoring using the distributive law backwards. That's 5 plus T pounds divided by 100 plus 10 T gallons. So C of T equals 5 plus T over 100 plus 10 T pounds per gallon. Now what's this expression? What kind of a function is this? It's a rational function. I got one here. It's a rational function. We've got a linear expression on top and a linear expression on the bottom. We can use what we know about linear expressions to analyze this. We can see that this thing is going to have a 0 when t is -5. So that we can sketch a pretty good graph. Okay, when t is -5, graph has to pass through 0. When t is 10, when t is -10, get rid of that 10. We're going to have a vertical asymptote. We know that the graph is positive out here. And what else do we know? Well, we know the graph is positive out here, because of course if t is a large negative number, both the numerator and denominator are going to be negative. Now between -10 and -5, the numerator is going to be negative, the denominator is going to be positive. So we're going to have a negative on this interval. So what's going to happen is the graph is going to have an asymptote here. It's going to have a negative asymptote here. It's going to come up through 0, and then it's going to go into the positives. Now at that point, this is what we know. We don't know necessarily what's going to happen beyond this point, but we can easily analyze that. We do a long division, 100 plus t into 5 plus t. Okay, so I've got room to do that here. And let me write it t plus 100 and t plus 5, because then the long division is going to look a little better. We're going to get 1. And then we're going to get -95. Yeah, that's what we would get if it was t plus 100, but it's 10t plus 100. Excuse my carelessness, or lack of attention, or whatever it is. Okay, it's 10t plus 100. Okay, so what we're going to have here is we're going to have 0.1. Because we've got to divide the 10t into the t, it's going to give us 1/10 or 0.1. 0.1 times 10t plus 100 is t plus 10. And then we're going to have -5. For the remainder, we're going to get plus 1 plus -5 over 10t plus 100. Now the -5 over 10t plus 100 is going to approach 0 when t gets large, and the 0.1 is going to be left for large t. So we could graph 0.1. So here's our concentration, here's our time, and let's just say that this line here is a concentration of 0.1. Okay, well, if we think about the graph here, this is a rational function with a 0 at t equals -10, because the denominator is going to equal 0 when t is -10. And we're gonna have to translate it a bit, okay? It's gonna shift over to -10, and it's gonna vertically stretch, but that's exactly the kind of thing we have here. We have this function pulled over here, and then raised up 0.1 unit. And that graph, if we correct it a little bit, is actually going to approach, okay, the rational function plus the 0.1 will approach 0.1. So now we take these rough conjectures, didn't draw that very well, but there it is. We have an asymptote here. And now we see the important part of the graph, because this isn't important. This corresponds to negative time, and actually at t equals -10, the container's empty. Think about it. And we see that the graph is going to do this sort of thing. So that for positive time after t equals 0, the concentration is going to be here, which is 0.05. And my graph isn't drawn to a very good scale now because 0.05 should be half of 0.1, but we can redraw it and make it look prettier. I'm probably going to ask you to do that. The graph is going to do this, and we see what's going to happen to the concentration. It's going to slowly approach 0.1. After 10 hours, it's going to be up to 0.075. Then after 20 hours, 0.0833, and so forth.